Okay, for our demos. So the nitrogen, starting to do it here, it's kind of hard to work with, so we can pour some out of it. I find just regular coolers work fine, so I'm going to pour some in the cooler. I know you're curious to see, but there's not much to see at the moment. Liquid nitrogen is just a completely clear liquid, so it simply looks just like water. Okay, so right now if you're looking at the bottom there, you just see a layer of just clear liquid. It just looks like water, okay? But you do kind of see the effects of it. In fact, when I do this, now, first instinct is you think, oh my gosh, we just saw the nitrogen. No, you didn't. You can't actually see nitrogen. It's invisible. So what did you see then? What did that remind you of? Smoke or fog or clouds, right? And that's basically what it was. The coldness of that nitrogen, when I blew the nitrogen out there, some of the nitrogen being so cold collided with water molecules in the air and caused them to condense into liquid form temporarily. So you basically saw a miniature cloud or fog there for a second. And then of course as it warmed back up, those water molecules went back into gas form, which became invisible. That's why they disappear, right? So you're seeing the effects of the coldness of the nitrogen. Okay? Now it's boiling there. You can hear like the little sizzling noise because obviously it's well above 320 degrees in here, so it's just boiling right on the top there. The layers down below are a little more protected because you kind of have to work, the heat's working its way down to it. So it should last just through the period to get through it here. Now to prove to you that we are well past the boiling point, I have a boiling point indicator, also called a tea kettle. Okay? How does a tea kettle work? You stick some water in there and you close it up, stick it on the stove, and how do you know when it's done? It starts to whistle. Now why is it whistling? How does it know?
Because the gas is going through the smoke.
Yeah, as the water heats up, it goes into the gas form, and the gas expands because it's hot now, right? But it has nowhere to go except for there's one escape. Escape at the little hole there. And they made a little whistle on that hole. So as the gas escapes out that hole, which would only happen, it's fine. As that happens, it's going to make a little whistling noise. So how long will it take for my liquid nitrogen to start it to whistle? Let me get a little liquid nitrogen down in here.
Oh, that's so cool.
See? So we'll put it in there. So as you can see, it's instantaneous, right? Because we only had to be at negative 321 to start it boiling, and we're well above that.
It's going at the bottom, too.
It's leaking out some holes there. And as you can see, there's nothing to pour out. Everything I poured in there is completely gone. All gone into gas form. That's a very quick process.
Can you drink liquid nitrogen?
It would kill you.
Well, what do you think would happen?
Freeze, turn into gas.
Yeah, you're putting something negative 320 degrees inside your body. I will show you what happens to organic materials in just a minute, so you can have an idea.
Is there like a material, like an element that if you literally just pour it right in the air, it just immediately evaporate? If you were just like pouring it, it just evaporate right when you pour it out?
If you pour it out, it'll mean this is pretty quick. I'll show you at the end here. All right, let me move on to my next demonstration. This one's kind of hit or miss. We'll see if it works this period. I have a ping pong ball here, and I put a very small hole. Let me see, there. Very small hole in it, and I tried to make the hole tangent to the circle, right? Instead of going down like this, I tried to make the hole like this. And the goal there is one, is to get some liquid nitrogen to go in the hole, and two, hopefully when it goes into gas form, it'll be trapped in the ping pong ball, but it has an escape hole, that one hole, and it'll shoot out at a tangent. So what would that do to the ping pong ball? So I got one time I got it to work for one of the periods, but the other one did not. So we'll see what happens here. Fill it up.
Ooh, it's spinning.
Sometimes, depending on how quickly it warms up, I've seen it go zzz. I've actually seen it take off before.
Oh, that is so cool. Ooh.
I think that's all. We'll try one more time here.
Want it to go up. Whoa. What's that?
It's squirting it out, yeah.
It's like gas. Water.
I think it squirted it most out. Yeah, it squirted it all out. Sorry guys, not a very good one. Try
What class did you get into work?
I didn't get to jump up. I got to spin pretty good on first period lead. Alright, I've got a bunch of little baggies here. And these baggies have my first period. Just blow them up and then we twist tight them. And we're going to stick them inside there.
They're gonna be boiled.
Now, what's going to happen?
Deflate or inflate? I don't know what.
Right. Usually your instinct's going to do one of two things, right? It's going to either expand or contract, right?
I bet they're gonna shrink.
Very good. So remembering, right? Coldness will cause the gas to slow down, which will contract. So I could probably put, 50 of those little baggies in there, or if not more. And as you keep putting them in, putting them in, and putting them in, they just get smaller and smaller and smaller, and you can just pack them in there. Okay? Now, it's kind of fun is when you get them out, and you get them squished down there. It's because once they get back into our temperature in the classroom, what are they going to do? So it's the same gas in there, but it's just taking a teeny little space now. But once it gets back into our temperature, those particles will start moving faster and faster. Let's just scoot this over. Top ones don't do so much, but it's more the ones on the bottom. And watch them come alive. Some of them will spring a leak and you need to pop. This guy's doing a good job. Oh, he just sprung a leak, I think.
I like it. So cool.
Yeah, he's got a tear on him now. I can see it.
The other one's not getting involved.
He may have tear. Like, this got a tear on him too.
Oh yeah.
Oh, he's got some liquid nitrogen inside him.
Oh yeah. He's pouring it out of the liquid.
Y'all need to refill some. I think these guys have all gotten popped. They've all